Hello guys, welcome to the channel. Today I'm going to explain about double-ended key. So what is a DEQUE? Double-ended queue, or DEQUE stands for double-ended queue, a data structure that combines the functionalities of both a queue and a stack. Flexible operations. It allows elements to be inserted and removed from both the front and the rear. We are going to name it as head and the tail, offering great flexibility. More versatile. This makes it more versatile than a regular queue. First in, first out, or a stack last in, first out, adapting to various data handling needs. DEQUEs are ideal for scenarios requiring efficient, flexible data access from both ends, such as implementing undo functionalities or managing a list of recently used objects. The resizable array implementation. ArrayDeque is a concrete implementation of the DEQUE interface, distinguished by its underlying data structure, a dynamically resizing circular array. This design choice provides significant performance benefits, particularly for core operations. The DEQUE has four main elements like addFirst, addLast, remove first, and remove last. So this design choice provides significant performance benefits, particularly for core operations. Support for 0-1 operations at both ends for adding and removing elements. It grows automatically as elements are added, eliminating the need to pre-specify capacity. Generally faster than linked list due to the better memory locality and no node overhead, making it a preferred choice for many applications. So why we should use DEQUE? No capacity restrictions, no element disallowed, high efficiency. As you can see this picture, this is the front and this is the rear, or this is head, or this is the tail. From the front we are going to dequeue the elements, and from the rear we are going to enqueue the elements. Core operations overview. addFirst, insert an element at the very front head of the DEQUE. addLast attribute, insert an element at the very rear of the DEQUE, means tail. Remove first, removes and returns the element from the front of the DEQUE. Remove last, removes and returns the element from the rear of the DEQUE. Peek first, retrieves but doesn't remove the first element. Peek last, retrieves but doesn't remove the last element. This operation provides compressive control over the data stored within the ArrayDeque, enabling versatile use cases. So let's go to the code explanation. DSA package. Package help recognize related classes in Java. In here, I import the ArrayDeque from Java util package. ArrayDeque allows adding and removing elements from both ends efficiently. In this, I declare a public class name as ArrayDeque. This class contains the main method that will run the program. In this line, the main method is the entry point of the Java application. Program execution starts here. In the seventh line, creates an ArrayDeque object that stores string values. We name it queue. Since ArrayDeque acts like a queue, we will use queue methods like enqueue and dequeue. Queue addLast string A. Add items at the rear, like enqueue the elements. We are going to apply same operation into the B and C. Next, system out println enqueue remove first. Removes and return the first element, head of the queue. Works like dequeue in a queue. The removed element is going to be the A. And the queue becomes B and C. And here prints the current state of the queue after removing the A. Okay, let's run this program. Here you can see we remove the first element of the queue. It's printed here as A. After the removing the first element of the queue, we are going to print the PC, and we can see the PC after the removing the first element of the queue. So there are common methods you should know when studying the queue. At last element, insert addRayDeque. Remove first. Remove the elements from front. Pick first. View the front elements. In stack operation, push mean push the elements to the top, mean add to the top. 4. Remove the elements from top. Pick. View the top. Other useful methods. Check the queue is empty by is empty. Check the size and check the clear. ArrayDeque combines all these features with great speed. When we should not to use ArrayDeque? You need random access. Use ArrayList. Don't. You need thread safety. Use concurrent LinkedDeque. Don't. You need to store null values. ArrayDeque doesn't allow nulls. Don't. So the conclusion, that's the complete explanation of ArrayDeque, a fast, flexible, and memory-efficient data structure in Java. and it's usually faster than linked list and stack. If you found this helpful, please like the video, subscribe for more Java tutorials, and comment what topics you want next. See you later, guys.